Hey guys, here is a video to talk you through some of the practice problems on here that will really just be helpful for this section or topic in general. I'm not going to go through these area circumference problems because there have been videos made on those ones already. So really I'm just going to be helping you with these arc and angle problems. All right, so before we go ahead and talk through those problems, I do want to talk about a couple of really important things here with this GeoGebra interactive tool. We did this with our Desmos activity the other day, and it's a really good way to see the relationships that we have to understand here. Okay, so when we create angles inside of circles, we have the inscribed angle, which is right here, angle beta, and that one is on the edge of the circle. Okay, whereas the central angle is the one that's literally on the center of the circle, as you can see here. When they both have the same subtending arc, which means right here, both of them have endpoints of C and B, that whole arc is being intercepted by both of these angles, and that's when the relationships that we're talking about come in. So the inscribed angle, as you can see here, I've got it on some nice numbers. If my inscribed angle is 45 degrees, my central angle that has the same matching arc, that's important, they have to have the same arc for this rule to apply. This one is 90. And that relationship is very important. That 90 is double the 45, okay? And if you look over here, the arc measure is also 90. These pieces of the circle itself, the arc, also have degree measures. So if I pick this up and I moved it somewhere, let's see right here. If we moved it to 71, or let me try to get a nice number. Here's a good one. 68, right? And you can see that that relationship is maintained. The central angle is 68, and sure enough, the inscribed angle with the same arc, CB, has half of that, which is 34, okay? The other thing that's important to note is that if we move this, right, notice how I can make all these different angles, but as long as I'm still with the same arc, it is still going to be that same exact relationship, and this angle will not change, all right? It also doesn't change no matter how big or small my circle gets. So that being said, let's go ahead and try some practice problems. Let's start with number 3. This is a pretty basic one. On Open Math, you can actually move this to your convenience, but let's just take a look at using the rule. So here we have some our angles, and so the central angle, if the central angle is 24, what would my inscribed angle be? And here, this picture is kind of important to look at. You can see that the central angle in this example is 60, and the inscribed angle is 30, right? So there's that half or double relationship. So if the central angle is 24, my inscribed angle is going to be half of that. So my inscribed angle would be then 24 divided by 2, and that's going to give me 12. So my inscribed will be 12 because that's half of the central. Now if I were to move backwards and I want to get my central from my inscribed, then I know that my inscribed is always going to be half of the central, so I need to double my inscribed, right? To get from 12 to 24, I had to double it. So to get from 80 to my new central, I have to double it. So that's going to give me 160. All right, and that is how you do your most basic problem with like central and inscribed angles. On to the next. Let's go ahead and do number 4. There's a really important concept here. There are no numbers on this picture, so you might be thinking, well, how the heck am I supposed to know anything, any angle measures, without any numbers? And what's really important to notice here is the arc that this angle is intercepting, right? We are asked for the angle WMV. That is right here. We don't know what this angle is, but we do know that it's intercepting this arc. And we also know that because the arc and the central angle share a degree measure, the inscribed angle is always going to be half the arc measure. So if we could figure out the arc measure here, we would be able to figure out what this angle is. In order to do that, it's really important to notice that this right here is a diameter. I'm going to go squiggly because I know I can't draw a straight line. So this is a diameter, And the reason I know that is because it goes through the center of the circle. Okay, so if I have a diameter whose endpoints are the endpoints of my angle and the arc, that tells me that this circle has been split in two. So, that being said, I know that an entire circle has 360 degrees, right? So if an entire circle has 360 degrees, I know that this part of it must be 360, and I know that because it's being cut in half by this diameter. Oops, this isn't 360. This is, the whole circle is 360. So this is going to be 180 because 360 divided by 2 is equal to 180. Okay, because the whole circle consists of 360 degrees. All right, so that being said, if this is 180 and my inscribed angle is going to be half of that, and we can write that down. Inscribed angle is going to be half of the arc. So arc divided by 2. So in this case, I would say, okay, well 180 divided by 2 is 90. So anytime, basically, here's your takeaway. Anytime you see that there's a diameter, okay, and you're trying to figure something out about the angle that is related to that or the arc, you're always going to have to notice a 90-degree angle. So really, instead of having a little curve here, we can instead have a box because we know this is a 90-degree angle. Anytime you see an inscribed angle that subtends half the circle for an arc, this is a 90-degree angle. It's an assumption that you're allowed to make. All right, next question. For this one, we have a couple pieces of information here, and we're trying to find angle BAC. That is BAC, that's this guy right here. So some of these problems take kind of multiple steps, right? This is an inscribed angle. Angle BAC is an inscribed angle. All right, so that being said, let's fill this gap in. That being said, we don't have any central angles to work with, but we do have some arc info, right? We know that this part of this much of the arc is 140. We can say that this part of the arc is 180, which means it's half the circle. And so we can actually figure out this last sector, and that would help us figure out what, let's use a different color, this matching one. That'll help us figure out the inscribed angle because it has the same endpoints. So the way we want to do that is ask ourselves, okay, well, a whole circle is a whole circle has 360 degrees. So to figure out what is left here, we could just take these two pieces and subtract them from 360. I don't know what I'm saying today, guys. So 360 minus 180 minus 140. Okay, once I subtract those, we get an answer of 40 degrees. So this is going to be arc BC. I'll actually make it orange. All right, now that we know that the arc is 40, we can say that the inscribed angle that goes with that arc must be half of that. Okay, so that's going to say 40 divided by 2. So that tells me that's going to be 20 degrees. All right, so we found out that this is 20 degrees. So you gotta play with it a little bit. It's like a puzzle. All right, on to the next. So this one's a little funny looking. It looks like kind of a lot, but just focus on what you have and what you're looking for. So we want to find angle HTV. So let's first find that angle. Yeah, that's gonna be this guy right here. So we know that this inscribed angle, this is another inscribed angle, is 21 degrees. This guy is 21 degrees. Okay. What else can we find just using that information? Okay. Well, we can say that the arc that goes with it, this is the arc that goes with it because they share endpoints, has to be double. So we can say that arc HV, it's a really ugly arc symbol, arc HV is going to be 2 times that 21 because arc is double the inscribed, just like the central. So HV is going to be 42 degrees. Your best bet is to draw these and honestly label the picture until you find what you want. All right, so we know this is 42 degrees. And then the next thing we can do is say, okay, well, this actually has the same arc. Okay, we actually didn't need to do this first step, but it's helpful to just to notice sometimes when you don't know where to go. This is another inscribed angle that has the same exact arc and endpoints as our given angle. Okay, so from what we learned from that GeoGebra thing, we actually know already that both of these have to be the same measure because they have the same arc. But in any case, we found out what the arc was anyway. So in this case, we could just say, okay, well, this must be 21 as well because they share this 42 degree arc. Or you could once again say, okay, well, 42 divided by 2 equals 21. All right. Now one more over here. I think that's the last one. Yep. All right. So for BGT, angle BGT, that is going to be this angle right here. That big angle. So the first thing we need to notice is that we have 2 arc measures here. That whole thing put together, this whole arc, is 150 degrees. So we know that arc BT or BRT is going to be 110 plus 40, which is 150. So if we know that this whole red arc is 150, that means that angle BGT has to be the same. So that is also going to be 150 because BGT is a central angle and central angles equal their arcs. And so this is our answer. And again, in case you forgot, if we go back to our GeoGebra here, central angle and arc, you see how these two are always the same no matter what we move, right? And because those are the same, the inscribed angle has the same relationship with each of them. All right, that's it for today. I hope that was helpful. And ask questions if you get stuck.